My dear students, today in this session we are going to see the topic hydrides and hydrogen bonding. Hydrides and hydrogen bonding. It is in Unit 4, the lesson hydrogen. So far we have learned structure of hydrogen peroxide, right? In the last video. Now we are going to see hydrides and hydrogen bonding. First we see hydrides. What are the hydrides formed from hydrogen? Two types of hydrides we can get from hydrogen. One is binary hydrides, another one is ternary hydrides. Binary hydrides example magnesium hydride and calcium hydride. Ternary hydrides example lithium aluminum hydride, sodium borohydride. So binary means two hydrogen, ternary means 4 hydrogen. Question number 2. Write the classification of hydrides. Write the classification of hydrides. So we have 3 types of classification: ionic hydrides, covalent hydrides, metallic hydrides. First we see ionic hydrides. These are hydrides composed of an electropositive metal, generally an alkali or alkaline earth metal. Here, lithium hydride, alkali metal is used, calcium and beryllium hydride, alkaline earth metals. Here, we have one condition for writing this ionic hydride. What is the condition? Lower electronegative than the hydrogen. The metal should have lower electronegative than the hydrogen. So the lithium hydride and calcium hydride, how it is formed? Lithium alkali metal react with hydrogen, the presence of 400 degree Celsius, it gives lithium hydride. Calcium hydride also the same way we can get it, the same temperature. Now ionic hydrides. Ionic hydrides, they are compounds in which hydrogen is attached to another element by sharing of 2 electrons. So most of the common examples of covalent hydrides of non-metals like methane, ammonia, then water, then hydrogen chloride. Covalent hydrides are further divided into 3 categories. One is electron precise, another one is electron deficient, third one electron rich. Electron precise, electron deficient Then electron rich, electron precise, methane, ethane, silane, germane. These are the compounds comes under electron precise. So electron deficient, diborane, B2 high 6, B2 high 6. Then electron rich, ammonia and water. Okay, here electron precise means what? The correctly electron shared among the atoms. Electron deficient means the boron in B2 high 6 diborane, boron has vacant orbital. Even if it is attached with 6 hydrogen, the boron has vacant orbital. Electron rich means what? In ammonia, nitrogen has one lone pair of electron. Likewise, water, oxygen has two lone pair of electron. That's why it is divided into 3 categories: electron precise, electron deficient, and electron rich. The third hydride, metallic hydride. Metallic hydride. So otherwise we can call as interstitial hydrides. Metallic hydrides are usually obtained by the hydrogenation of metals and alloys, in which hydrogen occupies the interstitial sites. Simply we can say that is voids. They are called interstitial hydrides. Here we will use some examples: titanium hydride, palladium hydride. So both are non-stoichiometric. Because with a variable composition. Some are relatively light and inexpensive and thermally unstable. Now, some of the hydrides, metallic hydrides, are stoichiometric hydrides: titanium hydride, zirconium hydride, hafnium hydride, vanadium hydride, zinc hydride. So general formula we can say MH or sometimes MH2. M means metal, H hydrogen, act as hydrides. Now let us move to the next topic: hydrogen bonding. Hydrogen bonding. How is hydrogen bond formed? How is hydrogen bond formed? The hydrogen is bonded with highly electronegative atom. So what are the highly electronegative atom? Usually fluorine, oxygen and nitrogen. These three are highly electronegative atom. The first place is given to fluorine. The electronegative means a tendency of atom to attract shared pair of electron towards itself, right? So any one of the electronegative atom is bonded with hydrogen, the bond is polarized. Due to this effect, the polarized hydrogen atom is able to form a weak electrostatic interaction with another electronegative atom present in the vicinity. vicinity. Present in the vicinity. Vicinity means near. The hydrogen is bonded with the electronegative atom. The electronegative atom again is make electrostatic interaction with another hydrogen, nearer hydrogen, because of polarization. The bond is polarized. That's why the statement is given: when a hydrogen atom is covalently bonded to a highly electronegative atom such as fluorine or oxygen or nitrogen, the bond is polarized. Due to this effect, the polarized hydrogen atom is able to form a weak electrostatic interaction with another electronegative atom present in the vicinity. This interaction is called as hydrogen bond. Actually, how much kilojoule per mole? 20 to 50 kilojoule per mole. Usually is denoted by dotted line. Hydrogen bond is mentioned with a dotted line in the structure. So in this topic, second question, what is the strength of hydrogen bond? What is the strength of hydrogen bond? It is a weak bond because it is merely an electrostatic force and not a chemical bond. Actually, the hydrogen bond is a weak bond, is merely an electrostatic force and not a chemical bond. Here, when the hydrogen is bonded with electronegative atom fluorine or oxygen or nitrogen, when we compare these three electronegative atoms, the fluorine is greater than oxygen, oxygen is greater than nitrogen. So the hydrogen bond is in the bond order HF is greater than HO, H, water, then HNH, so another one hydrogen is bonded with the nitrogen. Actually, it shows ammonia. Hydrofluoric acid is greater than water, is greater than ammonia. The hydrogen bonds are much weaker than covalent bonds. So when we compare the hydrogen bond with another type of bond, which place the hydrogen bond has taken, ionic bond is greater than covalent bond, covalent bond is greater than hydrogen bond is greater than dipole-dipole interaction and van der Waals force, London force. So hydrogen bond has taken the third place, right? Because it is weak bond. How the strength of the bond, hydrogen bond, is determined. When hydrogen is bonded with the fluorine, that is greater. Then hydrogen bonded with oxygen. Hydrogen is bonded with the oxygen is greater than hydrogen bonded with the nitrogen. According to the electronegative atom, the bond strength is determined. Fluorine greater than oxygen, oxygen greater than nitrogen. Let us move to the next question. What are the two types of hydrogen bonding? What are the two types of hydrogen bonding? It's very, very important. Intramolecular hydrogen bonding, intermolecular hydrogen bonding. Intramolecular means within the molecule. Intermolecular means out of the molecule. Right? Explain intramolecular hydrogen bonding. Explain intramolecular hydrogen bonding. The intramolecular hydrogen bonds are those which occur within the single molecule. So, within the single molecule, the hydrogen bonding occurs. Here, this type of bond is formed between hydrogen atom and nitrogen, oxygen, or fluorine atom of the same molecule. So, this type of hydrogen bonding is commonly called chelation. Chelation, right? So, is more frequently found in organic compounds. So, intramolecular hydrogen bonding. So, where we can get in most of the compounds, organic compound. In organic compound, we can get the intramolecular hydrogen bonding. Intramolecular hydrogen bonding is possible when a 6 or 5 member ring, organic compounds. So, what are the examples? Here, 3 examples we can find it. Orthonitrophenol, then salicylic acid and salicylate. Orthonitrophenol. In the first position, ortho position, NO2 group is placed, right? Because of OH, the first position is NO2. That's why ortho. First position means ortho. Here, the OH and nitrogen coordinate bonded with oxygen. The bond is between, the hydrogen bond is between hydrogen and oxygen. It's mentioned with dotted line. Here it shows one cage. Shows one cage. That is called chelation. The same chelation we can find in salicylic acid also. Salicylic acid, the benzene ring is bonded with COH group, acid group, and OH, alcohol group. Here the double bond O and OH, the hydrogen and oxygen, some dotted lines are given. That is called hydrogen bonding. So, within the molecule we can find the hydrogen bonding. Likewise, salicylaldehyde, the ortho position CHO group is there. Here OH, the same dotted line between oxygen and hydrogen. So, the same molecule we can find the hydrogen bond. This kind of bond is called intramolecular hydrogen bond. The intramolecular hydrogen bonding is called chelation, as I told you earlier. It decreases the boiling point of the compound and also its solubility in water by restricting the possibility of intermolecular hydrogen bonding. Question number 5. Explain intermolecular hydrogen bonding. The previous slide we have seen intramolecular. Intramolecular means within the molecule we can find the hydrogen bonding. And now we are going to see the intermolecular hydrogen bonding. Out of the molecule we can find the hydrogen bonding is between same or different compounds. So this type of bond is formed between the two molecules of the same or different compounds. Hydrofluoric acid, the bond here it is between hydrogen and fluorine, it's a solid bond, and another one bond will form here, fluorine and hydrogen. It is the next compound, hydrofluoric acid, but it's connected with hydrogen bond because of fluorine. Fluorine has more electronegative. Actually, the hydrogen fluoride, hydrofluoric acid, suppose it is a solid state, the hydrogen fluoride consists of long zigzag chain chain because of intermolecular hydrogen bonding, right? Because of the intermolecular hydrogen bonding, the structure even is changed. Long zigzag chain. So another one example is a very good example. There is a water. The water comes under intermolecular hydrogen bonding. Here, the electronegative oxygen atom in a water formula we know H2O. The electronegative oxygen atom forms two polar covalent bonds with the two hydrogen atom. Two polar covalent bonds with two hydrogen atoms. The oxygen atom has partial negative charge and the two hydrogen atom acquire partial positive charge. So in the water molecule, oxygen carries partial negative, the two hydrogen are carrying partially positive charge. The negatively charged oxygen forms two hydrogen bonds with the two positively charged hydrogen atoms of the two neighboring molecule. So each oxygen atom is tetrahedrally surrounded by 4 hydrogen atom. So in the diagram we can find it. Here 3 types of water molecules are given. So oxygen bonded with the 2 hydrogen. So another one molecule is here. Between these two water molecule, the hydrogen bonds we can find it in the mentioned dotted line, hydrogen and oxygen. Likewise, the third water molecule also is combined with the second one. So now you consider the oxygen. The oxygen is surrounded by 4 hydrogen atom. 2 are solid bond, remaining 2 are dotted line. The dotted line shows intermolecular hydrogen bonding. So out of the molecule. So between two water molecules it is forming. Right? That's why it is called intermolecular hydrogen bonding. Suppose you are going to attempt this kind of question. The statements you have to write it. So what are the statements I have given with the red color? That statements are the key points. The structure of ice. The structure of ice, while in liquid water, unlike ice where hydrogen bonding occurs over a long range, the strong hydrogen bonding prevails only in a short range and therefore the denser packing. So when we compare ice of water, the density is lesser than 0 degree water. 0 degree water. The ice has a long range order of hydrogen bond, but liquid has short range order of hydrogen bond. That's why the density of water in liquid is maximum. Here the structure of ice is given. The previous diagram, how the oxygen is bonded with the hydrogen and a neighboring water molecule hydrogen is surrounded by tetrahedral 4 hydrogen. 2 are solid line, remaining 2 are dotted line. So likewise in ice structure, the same water structure of ice, it is given like this. The same hydrogen bond occurs not only in a simple molecule but also in complex biomolecules such as protein. The biomolecules also we can find the hydrogen bonding. They are crucial for biological processes. For example, hydrogen bonds play an important role in the structure of deoxyribonucleic acid. Deoxyribonucleic acid means what? DNA. Since they hold together the two helical nucleic acid chain. Helical nucleic acid chain. In biology, we can find the diagram. The helical nucleic acid chain is called strands. Here, the color dots are given: oxygen, nitrogen, carbon, and white dot shows hydrogen. The dotted line we can find the hydrogen bonding. So the DNA molecule also have the hydrogen bonding. Thank you.